Today we're going to solve a system of equations with 3 variables, and this is very similar to the addition method or the elimination method with 2 variables. Basically, we want to eliminate one of these variables, and the way we're going to do that is I'm going to label these equations as A, B, and C, and we're going to take 2 of these equations and eliminate the same variable. Then take a different combination of 2 equations and eliminate the same variable from those, and then we'll be down to just having a system of equations with just 2 variables. Now, you can choose x, y's, or z's to get rid of, and the x's are going to be much easier to work with in this problem. So what we're going to do is we're going to take our equations a and b and we're going to eliminate x. Alright, so I just rewrote equations a and b. My x's they'll subtract or they'll add to 0. This is 5y, and this is a 1z, and now we have 9. Alright, so we eliminated the x's. Now we have to choose, we have to use equation C and either B and C or A and C, and we're going to eliminate the same variable. I'm going to choose to work with equations B and C, and I'm going to multiply this entire equation for B by a positive 2 so that my x values will eliminate. Alright, so I took my B equation and multiplied the entire thing by 2, and I rewrote my C equation below it, and we're going to add these together. That's 0, 8 minus 3 is a 5y, and 6 plus 2 is an 8z equals a positive 2. Right? And now what happens is I have these 2 equations that I got rid of the x's, and this actually just turns into a system of equations with 2 variables. So we're going to solve those like you would any other system of equations with 2 variables. Right? And so what we can do here is let's take this first equation right here, and we're going to multiply the entire thing by negative 1. So we get negative 5y minus z equals negative 9. And remember, multiplying the entire thing by negative 1 doesn't change the equation, it just changes its appearance. And we have this other equation down here, 5y plus 8z equals 2. Right? And we're going to add these 2 together and we're going to eliminate y. You could have chosen to eliminate z, but I thought y would just be easier, so I went with that. Negative 5y and 5y is 0, a negative 1z and an 8z is 7z equals, and a negative 9 plus 2 is a negative 7. So now we know z is equal to negative 1. And once we know z is equal to negative 1, we can plug that back into either one of these equations and solve for y. Alright, so I'm going to plug it back into here. We have 5y plus, and z is a negative 1. Negative 1 equals 9. So I'm going to add 1 to both sides. We get 5y is equal to 10, and now we know y is equal to 2. So we have our z and our y. Once we have those 2 values, just pick any one of these equations from the original part and plug those values in, and you can solve for x. I'm going to pick the first one because it has the lowest numbers. Alright, so I plugged y into the first equation, z into the first equation. I have x plus 2 minus 2 times negative 1 equals 7, and now we have x plus 2, and a negative 2 times a negative 1 is a plus 2 equals 7, so I have x, I'm going to subtract 4, and 7 minus 4 is 3. Alright, so my system of equations, the solution looks like 3, 2, and negative 1. And once again, you could check this by taking 3, 2, and negative 1, plugging it in for x, y, and z in all 3 of these, and it should give you these values at the end.